Hi, I'm Miss Igo. Welcome to my classroom. This is the second part of my video about the rectangular coordinate system. We're going to be talking about graphing linear equations, first by using t-tables and then by finding the intercepts. To graph an equation by using a t-table, we take our linear equation and we choose points to plug in for our x values. And we plug those values in to find the y values that go with them, and that creates a coordinate that we can plot on our graph. Here, they've given us values for x, but if we're not given values for x, we can choose whatever values of x we want to. I usually try to choose points that are close to 0. So -1, 0, 1, or 0, 1, 2, points like that. And then, like I said, we plug them into our equation to find the y values that go with them. So if we choose this first value for x, -1, I'm just going to write my equation and plug in -1 or substitute -1 in as the value for x. So if I simplify this, I get -2 times -1, that would be a +2, plus 3, which is 5. So this means when our x coordinate is -1, our y coordinate is 5. So that gives us the point -1, 5 to plot on our graph. Remember, the way that we plot a point on the graph is we start at the origin, or 0, 0, and then we do our x value first. -1 means we would travel to the left 1 space, and then +5 would have us go up 1, 2, 3, 4, 5 spaces. So I'm plotting a point there. All right, now let's go to the next value. So if we plug in 0 as our value for x, I have y is equal to -2, and I'm going to substitute in 0 for x, plus 3. When I simplify this, -2 times 0 is 0, and 0 plus 3 is 3. So when my x value is 0, my y value is 3. To plot that, I start at my origin, and my x value is 0, so that means I don't go left or right. My y value is 3, so from the origin, I'm just going to go up 1, 2, 3 spaces and plot my point. Now we have one more value to plug in. I'm going to substitute 1 in as my value for x. So I have y is equal to -2 times 1 plus 3. So I get y is equal to -2 plus 3, and -2 plus 3 is 1. Okay, so then I have the point 1, 1 to put on my graph, starting at the origin. I go to the right one and up 1. Now that I've plotted these points, and I can do however many I want to. If I wasn't sure about that, I could continue and plot more points. I could choose more values for x and plug those in to get the values of y that go with it. And then I would connect my points. It's best to choose at least 3 points, because any 2 points can be connected and create a line. But if you have that third point, if you plot 3 points and it's not making a line, then that lets you know you did something wrong. So I would always choose at least 3 points to plug in for my x values whenever I'm trying to graph using a t-table. So now I connect my points and put arrows at the ends, because that means that my line continues. It doesn't stop at those points, and that's how I would draw a line using a t-table. Okay, here's another example that we're going to graph using a t-table. I've chosen the points 2, 0, and -2. I don't know if you caught that, but there was a value in the t-table that wasn't supposed to be there, so I just erased that. So now we're going to plug these values in for x to find the values of y that go with them. You may be wondering why I didn't go in consecutive order or with consecutive numbers. And the reason why I did that was because if I were to choose 1 and plug that in for x, it's going to give me a fraction, which is okay. It's just harder to graph fractions. So this is just showing you that you can choose whatever values of x you want. And like I said before, I would choose at least 3 to graph your line. Now you would want to choose points that are close to 0 because here's your graph, and say if I chose to plug in -15, well, that's not even going to be on my graph. So I would choose points close to 0 and whatever points give me nice, pretty numbers to graph. So let's plug in 2 for x. So to solve this for y, I need to subtract 2 from both sides. I have -2y is equal to 6. And then I divide both sides by -2. And that gives me y equals -3. So I can plot that now, or I could wait until I get all my points and plot them, which I think I'm going to do this time. Let's go ahead and plug in 0 for x. Okay, so 0 minus 2y is the same thing as -2y. And then I'm going to divide by -2. And I get y equals -4. And the last value that I have is -2. And to solve for y, I'm going to add 2 to both sides. And I have -2y is equal to 10. Divide by -2. So y equals -5. So these are all ordered pairs. That's what I've created, is the ordered pairs. And if I plot these ordered pairs and connect them, that's going to give me my line. Okay, so I have 2, -3, start at the origin. I go +2, so to the right 2. -3 means I'm going to go down 3 spaces. 0, -4. If my first value is 0, that means I don't go left or right, but I go down 1, 2, 3, 4 spaces. And -2, -5, starting at the origin, -2 means I go to the left 2, and then -5 means I go down 5. And then I just connect these points to create my line and draw arrows at the ends. Now let's talk about graphing linear equations using intercepts. But first we need to define what an intercept is. We have 2 types of intercepts, X-intercepts and Y-intercepts. An X-intercept is the point where the line intersects the x-axis. So with the red line being my line and the black lines being my rectangular coordinate system, my x and my y-axis, the point where my line crosses the x-axis is my x-intercept. The y-intercept is the point where the line crosses the y-axis. On this graph, it would be right here, where it crosses the y-axis. Let's look at these graphs and identify the X and the Y-intercepts. On this graph, the X-intercept, again, is where it crosses the X-axis. So my X-intercept would be 2, 0. That's the point where it's crossing the X-axis. The Y-intercept would be this point right here. To get to that point, I wouldn't go left or right. So it would be 0, -4. My X-intercept here would be right here in the center, in the origin. So my X-intercept would be 0, 0. Where is it crossing the Y-axis? Where is my Y-intercept? It would also be at 0, 0. Where is the X-intercept in this example? Remember, the X-intercept is where it's crossing the X-axis. Our line is not crossing the X-axis at all, so there is no X-intercept. Where's the Y-intercept? The Y-intercept would be at 0, 3. I want to point something out where we have the X and the Y-intercepts, the coordinates for each of these intercepts. Here, we didn't have an X-intercept, but we did have a Y-intercept. So, if you'll notice, for my Y-intercept, I had a number for Y, but my X was 0. In this example, for my X-intercept, there was a number for X, but my Y was 0. Here, my Y-intercept, I had a number where the Y was, but my X was 0. So if you'll notice, for all of these examples, if I'm looking for my X-intercept, or if I have an X-intercept, the Y value is 0. If I have a Y-intercept, the X value is 0. Here again, I had a Y-intercept, my X value was 0. So always the opposite letter for our intercepts is going to be 0. And we can find those intercepts by doing just that, by plugging in 0 for the opposite letter. So these directions say to find the X and the Y-intercepts given the equation of the line and then graph. So here's my equation, X minus 3Y equals 6. So to find my intercepts, just like I said earlier, I'm going to plug in 0 for the opposite letter, for the opposite coordinate. So I'm basically making a t-table again, but I'm only going to look for 2 values. I'm going to look for Y when my X value is 0, and I'm going to look for X when my Y value is 0. So let's start with plugging in 0 for X. That's going to give me my Y-intercept. Okay, if I plug in 0 for X, (0 minus 3y is the same thing as -3y. To solve that, I'm going to divide both sides by -3. And that gives me y equals -2. Okay, so now let's find the X-intercept. So to find the X-intercept, I'll plug in 0 for Y. If I plug in 0 for Y, I have X minus, excuse me, 3 times 0 equals 6. Well, 0 times anything is 0. So that would just be X minus 0. So that just goes away. So X equals 6. So now I'm going to plot these 2 points on my graph. 0, -2. So this is my Y-intercept is at -2. So on my y-axis, I go down to -2. And then my x-intercept is 6. And then again, I just connect those 2 points. If you're drawing it on a piece of paper, it's best if you have a card. It could be, your student ID, driver's license, another thicker piece of paper to help you to draw the line straight. Unfortunately, I can't do this when I'm drawing on the screen, so my lines are not going to look real pretty. But that's how we graph a line by using the intercepts. Okay, let's look at one more example. Again, we're going to basically create a t-table using zeros for each coordinate. So if I plug in 0 for x, that's going to give me my y-intercept. Okay, 2 times 0 is 0, so that just basically goes away. But don't forget about that negative that's in front of the y. It doesn't go with that 0. So now I have negative y equals 4, but I don't want negative y. I want positive y. So if you'll remember, there's always an understood 1 in front of our variables. Well, that makes the negative makes it a -1. So to get rid of it, I'm going to divide by -1. So I have y is equal to -4. So that's my y-intercept, which means on my y-axis, I would go down to -4 and plot my point. And then for my x-intercept, I plug in 0 for y. So this time, that negative is going with the 0. So that just kind of goes away, which leaves me with 2x equals 4. And then I divide both sides by 2, and that gives me x equals 2. Okay, that's my x-intercept. So on my x-axis, I go to 2, plot my point, and now I connect those 2 points that I've plotted, my 2 intercepts, and that gives me my line. And that's how we graph using intercepts.